Hi, I'm Nick, AI developer advocate at Qualcomm, and today we're going to be building a local agent. Local agent is really cool because it does all the fancy stuff that other agents do, but now it runs entirely on your device. Before we get started, a couple things I want to talk about, starting with dependencies. This project will have three basic dependencies. One of them is going to be your choice. First is Python 3. I'll be using Python 3.12, but 3.8, 3.9, and later should work just fine. Second dependency is going to be a code editor of your choice. Again, I'll be using Visual Studio Code, but if you prefer something different, please feel free to use that. And lastly, we'll be using LM Studio as our language model server. LM Studio is an application that is platform agnostic, so you can install it on whatever computing hardware you have, and it will allow you to interact with models using Llama CPP under the hood. This QR code will take you right to the download link for LM Studio. So what are agents? I think that's a pretty important piece before we start to help set the context for what we're going to be building today. Agents are a type of software that interpret user requests, make decisions, and then take action in response to those requests autonomously. So you don't need to be present. It's good to watch what your agent is doing, but you don't actually have to make the decision. The agent will do that for you. Agents rely on the probabilistic nature of language models to analyze, reason, and act. Now, I have these three lines underlined in my slide because it's really important to understand that analyze, reason, and act is slightly different in the context of a language model. Analyze means it's able to look at what you type. Reason is, to the best of its ability, think about the scenario, though it's quite limited compared to a human's ability to reason. And lastly, act, meaning it can act within the parameters that you define. We'll see this when we build our agent, but just know that your agent is not going to take over your computer or do anything crazy unless you specifically give it instructions to do that. The cool thing about agents is that they allow you to move beyond static code where you're just defining a very specific workflow, and they're able to use this probabilistic nature and take more complex multi-step actions and complete tasks that are generally a little bit harder than a traditional computer program with if and else logic and loops and things like that. Now, agents are almost purpose-made for the edge, which is really exciting. I'm glad that we get to build one today. The reason why they're so good for the edge is that they have a lot lower latency when you compare to something that is using a network connection. So any of these cloud deployed models, you'll type in a message, it will send a request to the cloud, and you'll get a response back before it can act. And this happens for every reasoning step or every time it needs to use a language model. With edge models, you're able to completely remove this dependency of the cloud, and you'll be interacting directly on device. The trade-off is that generation can take some more time in certain instances, but it will generally work better overall and faster overall on the edge. Second is, because you're working at the edge, you have a lot more privacy in what you're doing. You can more safely use more sensitive data like medical documents or potentially financial documents or things of that nature and work them into the agent workflow so that it understands a little bit more about you and your context. These are not traditionally informations that you would send to a cloud server because it's a little bit too private, but now you can take action on them on your behalf with an agent locally. A couple good examples of agents that you might have seen in the wild are a camera that on its own can analyze video and take actions depending on what it sees. In the past, this would have looked like the camera recording something and then sending it to a cloud for analysis and then getting back information about the environment. Now we don't need that. You can analyze the video entirely on the camera and then only send certain instances back to the cloud, which helps save a lot of bandwidth and really free up resources for other interesting tasks. Another good example that you might be familiar with if you're a student is a research agent. You can task a research agent to go look up information. And we're seeing some of these in cloud language models, and they're called deep research or something similar to that. And they essentially compile information and then read through information. You can do the same thing on your own on the edge and have it be a little bit more targeted to your specific use cases there. And then lastly, another cool agent use case is a home automation system. A lot of people these days are getting a computer that they already have lying around. They're connecting it to their local network, And they're discovering that they can connect to various IoT kits or other computers or components within their home that help them do things with a little bit more freedom than just always pressing a button or going to a light switch to turn it on. A simple use case would be hooking up all your light bulbs and setting them to an automated timer. An agent can look at that and say, maybe it's better today to turn the lights on a little bit later because I noticed that as time goes on, the sun is staying up longer and we don't need the lights on. So it can make choices like that at the edge without you needing to be directly there overseeing everything, as long as you are taking steps to oversee it from a higher level and making sure it's not acting erratically overall. Agents are really, really cool because they are what will likely allow us to usher in a new era of computing where AI is the UI for a user. So gone are the days, or gone will be the days, where you used to have to open a computer and interact with the operating system and the file system and know what was going on to get the most out of it. Now the agents know that for you. So if you can communicate directly with an agent and tell it what you're trying to do, as agents get smarter, they'll become more capable and be able to handle more complex tasks so that you don't have to think about how they're done on the computer, but rather focus on the intent and getting the job done. Now that we have a good high-level understanding of what agents are, I want to break them down into three main components to help you understand them and conceptualize them a little bit more clearly. The first part is going to be the model. The second are the instructions that guide the model. And the last component are the tools. The model itself, you can think of as the brain. It's going to process the user input and the language that they're communicating in. It's going to use that model to understand the request and then ultimately take decisions based on what it knows about the world through that model. The instructions are system prompts that are user provided and user customized that help guide the model as it is reasoning and trying to understand requests. These can be system prompts, but they can also be prompts that are added to the system prompt when you're making a specific request. You have a lot of flexibility here, and we'll take a look at that in the code. The last component are the tools. Tools are great because they give the model functionality beyond what it's able to do as a model. Today we're going to be building a time tool for our agent, and I chose this one specifically because it's a classical example of things that language models just can't do because they're not good at them. Most language models, if not all, have a knowledge cutoff date. And this is a point where the model creator said, we are not going to certify that the knowledge that comes out of this model is correct or not. So you generally can look through the documentation and they'll say the cutoff date is so-and-so month and year. Because of those cutoffs in the knowledge, a language model can't do things like look at the time, tell you the date, review current events, things of that nature. And so by building a time tool, you're now giving your agent the ability to understand where we are in the physical world to some extent more than it could before. So the time tool is a first stepping stone, but you could take that and ground it into more interesting functionality beyond just telling the time, such as get me a review of the current events for today, or anything interesting coming up in the next 2 weeks near me. And an agent will be able to go out and look at these things based on the context of the date today. Now, last piece I want to touch upon here, which again we'll see while we're writing the code, is that agents are very composable. So the structure of an agent as we build it today is somewhat loosely defined in that you need to have the model, you need to have instructions to guide it, and tools for it to call. But you can generally extend and shrink each of these components to really fit your needs. If you only need 1 or 2 tools, great. You make 1 or 2 tools and you have a very minimal agent deployment. On the other hand, if you're really interested in multifunctional agents, you can give it tools that it sometimes has access to, or give it access to different models all at once, or even modify instructions or layer on instructions as you're talking through the agent. We're not going to go that deeply today, but I just want to highlight that the nature of agents being so composable really gives them a lot of power, and we're just getting started with understanding how we can really use these types of computing systems. Last thing I want to look at before we get started today is a little bit of an outline of what we'll be doing today. First thing we'll do is we'll go and I'll show you how to download the model server that we need. We'll install the requirements, which are in a requirements.txt file. There's not too many for this project, just 2. Then we'll go through and set up our repository. We'll build first the model class, then we'll build the tools class, and we'll end with the agent class. Those will be the 3 main components that the agent needs to function correctly. Once that's completed, we'll go back and look at the agent configuration, which is in a YAML file so that you can easily modify the variables. And we'll wrap that up with a main that invokes all of the different code that we've written and actually run your agent. If you're interested to see the complete code with a little bit more addition and things we might not cover today in this video, feel free to check out the repository at the QR code below. That contains all of the code with documentation to get set up, and you can just clone that and get started right away. With that, let's get into the code. Before we dive into the code, first thing I want to do is take a look at the README. This README is from the official GitHub repository, which we'll take a look at in a moment, but I just want to walk you through what's available if you choose to go and just download the code directly. I've included a table of contents so you can easily navigate to all these sections. Most important for you as a developer are the requirements here, which are very minimal, just OpenAI and PyYAML within Python, as well as LM Studio, the application I mentioned earlier. Once you have those various pieces installed or available, you can follow these setup instructions straight through to set up the environment for yourself. We'll be doing this a little bit later on in the video. One other section that's important to look at is this adding more tools section. Hopefully it'll become apparent during the video today how we can build these tools and how you can extend it on your own. But if you're ever unsure, you can always go back to the repository here and see how I've set up the tools class and how you can extend it from there. Down at the bottom, I have a couple contributing notes. If you're interested in adding to this repo, I'd love to have your contributions, and feel free to reach out anytime if you have questions to Qualcomm Developer, through our Discord channel, or by email as well. With that, let's go take a look at the repository. The repository is located at github.com/thatrandomfrenchdude/local-agent. It has an MIT license, so you're free to take this and do whatever you need to with the code. It's meant for you to understand agents better. The README on the repo is the same one we just looked at, and I have the code organized within this source directory here, and these are the modules we'll be building today. Please note, I haven't pushed up the virtual environment, and I haven't pushed up the config file. Those are going to be for you to generate on your own as a developer in your local space. The other resource I want to share with you is LM Studio. You can find that at lmstudio.ai if you haven't scanned the QR code from earlier. And on there, you want to make sure you grab the correct LM Studio version for your machine. On mine, that's going to be this one right here. And yours should show the correct version. One other thing to note as well is that LM Studio has recently released SDKs for both Python and JavaScript. I will not be using those in the video today, but they do allow you to interact with models and the model server programmatically if you prefer to do it that way. To get the download of LM Studio, you can click this download button and it will begin the download. This is the environment I'll be working in today, so I've created the 5 files we'll be writing out. We'll start with model.py, then we'll fill in tools.py, followed by agent.py, and once we have those 3 main components filled, we'll go and fill in the configuration, and then followed by the main to wrap up the code and run it together. In order to keep that process smooth, I want to take you to LM Studio to set this up first, because the model can take some time to download. LM Studio has 4 different tabs on the left side here. You'll be dropped in likely to one of these, likely the chat tab. In order to find models, which is the most important piece here, you can go to this search bar to discover, and you can search in a model that you need. For today's video, we're going to be using Llama 3.2 3 billion instruct. So I'll show you what model that is. I'm using Llama 3.2 3B instruct Q8 from Hugging Quants, but any of these models that are instruct labels should work for you. Please note, as we discussed before, language models are probabilistic, so it's possible that your performance may vary, and I would highly encourage you to explore different instruct models and other models as well to help you find one that fits your use case. One thing I did notice in my experimentation is that reasoning models tend to have a harder time with tool calling because they think through the problem first, and then they use that thought process to develop the final answer, as opposed to just generating the answer all at once. This can cause some unpredictable behavior, so your mileage may vary if you choose a reasoning model. I already have the model downloaded, but you'll see here a couple different options for different quantizations if available. And down here, you should see something like download model. So you can click that and it will start the download. The download will happen over here in this little left-hand side. And you can see that I've downloaded my models previously. And when it's done, it's going to show up in this folder right here, which tells you what models you have downloaded and how much space they're taking on your machine. Another cool thing too is while you're running the models, you can click over here and it will tell you information about the models that are loaded and how many resources they're taking up. To load the model into the server, choose the Developer tab over here, and you'll be able to use this window to load your model in. On the left-hand side, you have a couple different options. Take note of this just-in-time model loading option because that will allow you to choose different models depending on what you specify in your code. If you don't have that enabled, you have to come up here, select the model, configure the parameters based on whatever you like. I'm going to leave the default here, and then load the model into the server. You'll see it's loading up just like that. And when you're ready, you can click Start Server. And now your model server is ready to start taking API requests. If at any point you want to come back and change something, you can stop the server, you can eject the model and pick a new one, or leave it as is. Let me just put my model back here, and we'll get started. For the code, we're going to start with the model. First thing I'm going to do is pull in the imports. Import YAML, and from OpenAI, import OpenAI. LM Studio is cool because it allows you to use the OpenAI format to hit the LM Studio endpoints, which gives you a lot of flexibility if you choose to change your model endpoint. Say you don't want your agent to run only on the edge, you can now change this to use an OpenAI endpoint if you have an API key to use with that. You can also choose other model servers here, but today I'll only be implementing the LM Studio endpoint inference. One other note is I have brought in imports from a Python package, but we'll set up the virtual environment when we get to the configuration section. I'm going to add a couple of details here, which are, this is a type for the messages that we send, just to keep things clear. It's a dictionary with 2 string parameters. And below that, I'll set up an empty class for a model interface. Again, this could be just a function, but I'm choosing to do it as a class because I think that it will be most helpful to do it as a class because then it's extendable later on. So I'll leave this blank for right now. We'll have the initialization function. And the only other one I'm going to put in here is a chat completion function, which again is going to take self without a K, and then we'll just pass it right there. So that's it for the model interface. If you watched the chatbot video, which we released previously, you'll find that the initialization function here is pretty similar. It's the same setup of using a YAML configuration file, which as I mentioned, we'll set up. So you're going to pull in all those variables and just configure the interface so that it knows how to talk to the endpoint that you're targeting. So I'll do that here. I'll add a little doc string model interface class for communicating with model. You can put whatever you want in there that's helpful for you. Then we'll do with open, and we'll pull in our config.yaml file. And that's going to be in read mode. And then I'll just say as f, we'll just read in our config. So config equals yaml.safeload. And then we'll pass in f, our file name here. So that's going to load in all the variables from the configuration file. Second is we want to assign some of these so that we can access them later within the class. So our model, as we mentioned, is going to be the instruct model. So it's going to be config.get. And then the first response is going to be our key from the configuration file, which is model. And we'll have a fallback just in case. That is Hugging Quants / llama-3.2-3b-instruct. Just like that. One other thing to mention too is that the model names are not exactly what you see in LM Studio. So you have the model name here, and then Hugging Quants is the folder that it's living in because that's who made the model. That's in the LM Studio documentation, so you can go ahead and look at that if you want to use other models, but for what we're doing today, that's how you set it up. Once you have the model set, it's only a couple other things to do. We need to set the LM Studio URL. We need to set a dummy API key. In this case, LM Studio doesn't require it, but you can just set something because the OpenAI interface needs that, and then we'll set up our client that we'll be using. So LM Studio URL is going to be as well config.get, and we'll use our key from the configuration file. So LM Studio API key. And again, we'll have a fallback value here, which I just chose as LM Studio. You can use any value right here. And then similarly, I'll pull out the LM Studio API key. My bad. I got those mixed up. Let me just fix that really quickly. I'll just go copy this one since I already filled it in. And this top one is actually supposed to be just the URL. So LM Studio URL. And the address for that, again, you can get this in the documentation, is HTTP localhost. And then it's going to be at port 1234/v1. This is the base URL, so all the other URLs that you need to build on top of, you can just use this as that base. The cool thing, though, is that the OpenAI wrapper wraps around all of this, so it's abstracted away and you don't really need to worry too much about it, which is what we're going to build here. So we'll have self.client is equal to OpenAI, which is what we imported earlier, and we'll give it the base URL equals LM Studio URL, and then we'll give it the API key equals LM Studio API key, just like that. And with that, our model interface initialization function is set up. Next thing we're going to do is we're going to fill in the chat completion. So again, use a language model to generate text, just like that. This is going to be using LM Studio, but again, you can extend this as you see fit to use other models, and you can either do that within the interface itself and make a general interface that can then be passed into specific interfaces for LM Studio or Llama or anything LLM, or you can just put it all in one, depending on what you prefer as a developer. There's a couple things we need to pass in besides self, so I'm going to go in and add those right now. And I'm going to add them on new lines just for clarity's sake. I set that up. First thing is the messages that we're passing into LM Studio. So those are going to be messages, and just for clarity, I'm going to say these are a list of messages, just like that. Under that, we'll have the temperature, which is going to be set to default at 0.7, and that's going to be a float. And I'm going to, like I said, 0.7. You can modify this, and I don't believe that I'm passing in anything to modify this in this code specifically, but it's there in case you want to change it. And then the last one is stream, which is also going to be set to false for this video. LM Studio, of course, like other servers, have the ability to stream the responses back, and you can handle those. It's super easy, actually, if you use the Python SDK to do that. But for the video, I'm not going to do any streaming. We'll just do a blocking chat. And the time function that we're building is going to be pretty quick to return the value anyway. So with that, we have a couple lines of code to add in here. We have response is equal to self.client.chat.completions. If you need to understand what's going on there, you can go read the OpenAI documentation where it explains this little wrapper that they have to set up the client. And then .create. And here's where we're going to put the information in. So model is going to be self.model. Messages is equal to messages. And then temperature is temperature. Just like that. And then lastly, you need to return the response that you get. So we'll do return response.choices. It's going to be 0.message.content. And that's it for the interface there. Like I said, we'll come back and install the configurations, and we might come back and take a look at this when we're testing it if there's any typos or issues. But it's not too much to actually get started interfacing with models. Next, we'll mosey on over to the tools file. This is where we're going to be building a tools class that the model can use, and then build the actual specific tools that use that class to be used by the model. So a couple imports that we need here. So from datetime, import datetime. And that is only for the tool that we're using today. Beyond that, this is all going to be pure Python definitions with a couple types here and there as I see fit. So I'll set up the boiler code for that. We'll say class tool, and we'll do def init. We'll pull in self and pass. And that's going to be it for the tool class. We're not going to add any other functions here, but I am going to add a couple other functions that will fill in. So time tool, this is the actual tool that we're going to be building today, which is going to take no values in, and it will pass. And we'll fill in a little bit of code after we filled in these two sections. So for the tool, we're going to have 3 different sections, and I'll talk about them as we go. Actually, I do want to add a run function. Forgot about that. That's actually the part where you're using the tool. And it's going to have 2 arguments, which is the self and then argument in the case that we do end up passing in an argument for the function that we call. So I'll leave that there like that. We'll fill in the init function. 3 pieces we need are self.name equals name. And then we have self.func equals func. And then lastly, self.description equals description. It's very hard to type while you talk, so let me just go back and fix that right there. And we'll pull in these 3 arguments into the function call. So we have name, we have function, which is going to be a callable, and then we have description. Name and description are strings. Description. There we go. Okay. So before I implement the run function, I just want to call out why we're building this. We're labeling the name, the function, description. You'll see when we get to it a little bit below after filling in the time tool that the agent needs a way to be able to understand the tool. So the tool class is actually what helps you structure the tools in a way that the agent can actually understand them and leverage them. So you need the name and you need the description because that's what you pass to the language model to get the context of the tool and know how to call it. And then the function that's defined there in self.func is going to be the actual function that gets called. So in our case, that's going to be this guy down here, the time tool, and we'll fill in that in this run section here. So the run is actually pretty easy. It's just going to be a single return statement, and it's going to call one thing or the other depending on if we have arguments. So it's going to be self.func arg if arg is not equal to an empty string, because it might be empty if we don't have anything, and else it's just going to call self.function, just like that. This is a pretty basic argument handling, so it's only going to take a single argument, and it's not going to handle multiple arguments or really complex functions, so you'll have to extend this if you want to do something more complicated, but the basic logic and how you would unlock this is there. Now, for the time tool, this is also going to be a pretty simple tool, and I'll add a comment here so you can understand what's going on in the function, but really it's tell the current time. That's all it's doing. So first thing we'll do here is we'll do now equals datetime.now, and that's going to give us a Python time string. And then under that, we'll just do our return statement. So return, and this is going to be a string that's formatted. Feel free to put whatever text you want in here. I'm going to write something basic. So the current time is, and then I'll fill in a little formatting thing, which I'll come back to, on, and then here's where I'll have the date. So altogether, current time is blank where we'll insert the time, and then on blank where we'll insert the date. So these are going to be regular expressions. Actually, excuse me, these are going to be now formatting strings. So I'll type them out. I'm not going to narrate them because they can be a little bit complicated, but just copy this or feel free to modify as you see fit. Maybe you want a special time format or you don't care about the seconds or the hours. So This is totally up to you. There's no right way to do this. I'm just suggesting a path to start from. So now.string format time. And then I like to do all of my functions at once. So .lstrip .lower. So ultimately it'll be returned lowercase. Inside of lstrip, we'll pull off any extra zeros that we have. And in the string format time, the format that we're going to want to use is %I. And then we'll use %M. And then lowercase %p. I don't know off the top of my head exactly the formatting. I generally just look at the docs and pick the right ones depending on how I want it formatted. And you'll see what this is going to do is it's going to say the time is now 10:17 a.m. on, and then it'll write out the date. So we'll see that when we actually get to the running portion, what it looks like in the formatting. And the date is very similar. So it's going to be now.str format time. And then for the date, it's going to be %D, %B, and %Y, just like that. So just to make sure you can see it all together there, that's how it's going to return the time. And as you'll notice, the time tool is just returning a string. This was another intentional choice that I made. The agent knows how to handle strings. So at its core, an agent is a chatbot that you as a user are interacting with, and so you can choose how it's going to handle these functions. So in my case, I asked the functions to return strings so that if the agent gets back a response from a tool, it knows it can just output that directly to the terminal. If you want it to think more or do more intricate things, feel free to modify this behavior however you need depending on your functions. What's next? Well, we have our tool class, which is the interface for the agent to understand the tools, and we have a time tool, which is a function that the agent can use to tell the time. What we need to do now is link this time tool to the agent by using the tool class. So it's a pretty simple process here as well. I'm first going to create an object of tools. It's just going to be a list. So it's going to be tools equals an empty list, just like this. And I'm going to add in my tools here. So in this case, we're only doing one, but if you have multiple, you just extend the list with all of your tools. So tools equals tool. And then inside of that tool, you just need to provide the 3 portions that we talked about above. So the first one is going to be called time, because that's the name. I want it to just be time. The second one is going to be the callable function it can use. So we'll pass in time tool, and that should not be a string. It should be directly a function that can be called. And the last one is the description. So for this, I'm going to write prints the current date and time. And then after that, I'll write usage, and then it will be return single quote, time, parentheses, single quote. Now, couple things to note right here. The description is totally up to you. As the developer, there's no right way to write the description of a tool. The goal is to maximize the utility of the tool by the agent. So I tried a couple different things here, and I found that this specific time works well. When I ask the agent to tell the time, all it needs to know is how do I print the current date and time, and it sees this in the system prompt, and it will then choose the function based on the usage that I provided. It's important that you remember to provide the usage because the agent doesn't know off the top of its head how to use the function. So you have to give it all of these contextual clues, just like you're talking to a person who's trying to do something for the first time. Agents are very similar. Every time is essentially their first time doing something, unless you have a memory system that you've implemented. And so you want to make the description short, to the point, and very useful, just like this one. So I'd encourage you to explore and try different things just to see where the bounds of possibility start to break down and the agent doesn't perform as you would expect. That's it with the tools there. One last piece we need to do is now build tool descriptions, and this will come in handy when we go back to the main function at the end, but I'm going to build it now because we're focusing on the tools. So the tool descriptions are what we actually use to pass into the agent. So we've defined the tools object there, which is essentially wrapping our tools in an agent understandable format, and then the descriptions get passed in the instructions. So I'm just going to do a pretty generic thing right here, which is going to be a new line.join. And inside of my join function, every single line is going to be a formatted string. And it's just going to be a bulleted list. So just like you would present the information to a person and say, here's the 3 tools you can use and provide bullet points, you can do the same thing for an agent because it understands language and context in a very similar way. So I'll do F and I'll do tool.name. And then we'll have tool.description here. And then we'll do a little inline loop for tool in tools. So I'll have describes the tools for the system prompt. Like I said, we'll see that when we get to the main file, but I wanted to set it up here. So all in all, we have our tool class that we define at the top, which gives us a structure for the tools to be provided to the agent. That's our software interface, essentially. Underneath that, we have the function, and this can be any type of function you want. Obviously, Python lets you do a lot of things with the computer, so we're just telling the time here, but if there's more intricate behavior you want to be able to accomplish, you can definitely define those and even use composable functions to put in different pieces or different loops. You know, really the sky's the limit in this case. Once you're done with that, you just need to create a list of the tools that you can access for the agent. And then the last piece is generate the tool descriptions that get passed into the system prompt. So all of these will come together as we get further in the video. The last component we're going to build before we get to the main is the actual agent class itself. The agent class is going to use the model interface and use the tool interface that we just created to give us a structure for our agent. And then we'll call that agent structure within our main file. So let's start with the imports like last time. We need some regular expressions in this one. And then we'll pull in from source.model. We're going to import that model interface. So import model interface. And then likewise from source.tools, we're going to import tool, which is a type. And I personally like to split my imported libraries from my generated libraries so that I know what's what and can keep things a little organized. So I'll do that there. And then I'll define my agent class here. So we'll do class agent, and that has nothing there. We'll have our def initialize function. As usual, that takes self. We'll come back and fill that in. And then the other function I want to define here, just like in the tool function, is a run function. So def, it's going to be run. It's going to take in self, and it's going to pass. And that's all we need for the agent. Again, this is a pretty simple explanation of how agents work, what they are. So my agent is only going to be able to take one reasoning step at any point. So you'll see that as we fill in this run function. But just know, and I'll mention it as we code, that you can go ahead and extend this as much as you want. You can give it time to think. You can give it parameters to go and do interesting things with all the tools. You know, you don't need to be limited to what we're doing in the video today. In fact, I'd highly encourage you to try and push the boundaries and see what you can do that I didn't talk about today. So let's set up the initialization function. So I'll drop this self down here again because we have a couple other parameters to bring in. First one is going to be tools, and that is going to be a list of tool to set the type. And then we'll have instructions, which we'll fill in shortly. And that's going to be a string. So I will put that here. I've been a little bit lax with the typing, but I'm just putting it there since I don't have a default value. And we'll set up a couple of pieces here. So first thing is self.model equals, and that's where we'll instantiate the model interface. So everything, as you remember, is set up there. So we just need to call it. And I'll add a comment here to say this is the model used by the agent. Again, you can extend this as much as you want and make it really complex if you're interested, or keep it nice and simple if you don't have a lot of resources to work with on your device. Next section here are the tools. So we'll give it self.tools, and this is a little bit like putting a tool belt on, because now the agent knows what tools it has access to. And so you'll see it's going to be tool.name tool for tool in tools. And this is very similar to, if I flip back for just a moment, it's very similar to the tool descriptions. The only difference here is that in the agent class, we're just giving access to the tools themselves. So in the tool file, we give the descriptions, which are provided through the system prompt. And in the agent's class, it contains all of the tool functions directly, so it knows how to call those. So I'll annotate that just so you understand. Tools available as functions to the agent. And then the last piece we need to add here are the instructions. So self.instructions equals instructions. And this is going to be agent instructions to set behavior. You can be as complex or as simple as you want. Again, you may break down a little bit when you're in an agent, especially at the edge, because you have less resources to work with. But you'll see when we implement this in the main how flexible it is. So we won't talk too much about the instructions here within the agent. We'll just look at them when they get defined a little bit later on in the video. And that's it for the agent initialization. So this mirrors the presentation that we had. We have the model, we have the tools, and then the instructions, which are the three core components of an agent. In the run function, we're going to be building how the agent runs. I made a couple of design decisions throughout that I will call out as we go. So if you see anything that's surprising, I will be sure to comment on that. First thing we need to do is add in the extra arguments, because there's one argument to add, which is going to be just the user input. So in addition to self, we'll have user underscore input. And because we don't have any default, I'll just specify that it has to be a string. Now, the first design decision I made here is that I'm just using a hard-coded history. So when our agent is interacting with the environment right here, it's only going to have a very limited context. So what do I mean by that is normally you can pass in a little bit more context to the agent by giving it more of the chat history. But in my case, I'm just going to give it 2 messages to work from, and the rest is just going to be whatever the agent generates. So the first message, each of these has a role and then a content key that are filled in with values. So role, and then I'll put an empty string there for a moment, and then we'll have content, and then an empty string there as well. And this is going to be the same just below in the message. And one other call out is you can totally go ahead and put these all on a single line. I'm just splitting it up for visibility purposes so it's easier to read. Especially when you're developing, it can be helpful to just make things as readable as possible. And then when you finally get to the optimization production stage, you can start to remove some of this and shrink it down so it takes up less space and is less readable. So first one, like I said, is going to be the system prompt. And then the second role that we're going to have is the user. So this one down here, I'll start since I'm here, is going to be just the user input. So content is that was passed into the run function. And up here, the content is going to be the self.instructions that we gave it. So self.instructions, just like that. Now, as I mentioned, you can go ahead and add more history here. You can manage it. LM Studio, when you use the endpoint, it doesn't maintain the history for you. So you do need to implement that yourself if you want to. But in this case, it's only going to receive the instructions that say, hey, here's the tools we have available, which again, we'll build in a second. And then it's going to pass in what the user asked the model to do. After we have the history, there's one other thing. Again, this was an intentional design decision that I chose here. And it's how we're going to recognize that we're doing a tool call. So I call this variable the tool call pattern, and it's why we imported the regular expression. So re.compile. And all this is doing right now, before I type out the regular expression, is it's going to be looking for the function name that we defined. So if I go back here, we called it time with a capital T. We called it time with a capital T, and then I'm going to add parentheses on it, just like if you're calling a normal function in Python. So it will be time, capital T, parentheses, and that's how your model will know. So in order to capture that, you can just enter this regular expression in here. So let me just add the fallback really quickly, which is re.all. And the expression that we're going to use is a little bit wonky, so I'm not going to narrate this. I'm just going to make sure that I get it right. Dot star with a slash, just like that. Slash is the escape character. So again, regular expressions can be a little bit wonky and hard to deal with, but essentially this beginning section over here is saying we want the start of the string to be the name of the function, and then we have a slash for the first parenthesis, and then we have whatever is between those slashes in case there's arguments, and then we have a slash for the second parenthesis at the other side. And then just for a little bit of extra clarity, I'm going to add a comment above this, and I'm going to say looks for tool calls in the form, and I'll do function, parentheses, where function is replaced by the tool name. Again, these are all design decisions. You can totally modify this. You can rename your tools different things if that's how you want to do it, but really let it be about what works for you as a developer and a designer when you're implementing this code. Okay. Next section after that is we'll call the model now, because we have the history that we're going to pass it, and we have the tool call pattern that we know to look for after. So we'll get our response. So call the model. This is going to be response equals self.model.chat completion that we wrote earlier. And we're going to pass in the history. Just like that. This is the history above, and you can see why every time the run function gets called, we're not modifying the history. It's really hard-coded, and you're just passing it through to give the model a little bit of context, and it's just running blind one shot with what you give it. After you get the response, the next thing is to check for a tool match. So check the output for a tool match. And this is only to capture the match right here. So match equals tool call pattern dot match, and then inside your match function you have response dot strip, so to strip off any extra characters. So this essentially, if there's a match, it's going to capture and create a match object, a regular expression type, or it's just going to have none because there was no match. And this is where you can then set, okay, if match, do something else, do something else. I always like to start with the do something else because it sets the base case. So if we don't see a match to our tool call, we just want to fall back to the traditional chatbot behavior, which is generate a response and send it to the user. In that case, we can just use the server as we can use the response from the server as we got it. We don't have to do anything else. So I'm just going to add this piece here again, intentional design decision, history.append, and we'll add in that same chat template as above. So I'll go grab that and then paste it in right here. Just like that. There we go. Okay. And we want to change a couple things. First is we need to change the role to assistant, and then the content is actually going to be the response.strip. Response.strip, again, that we did ahead. So again, just what's going on here is, actually, let me add the return statement too. Don't want to forget that. Return response. .strip. My bad. You can also choose if you prefer to just strip it out at the beginning. I'm just going to leave it like this. So what this is doing is we've now called the model up here. We checked for a match, and we assumed that match was false. So there was no match. So all we're doing is we're appending the message back to the history, and we're returning the response that we got as it was. So the classic example for this is we have a time tool. If you ask it, what's the capital of France? You would expect it to say the capital of France is Paris. And it doesn't even need a tool call, and it's going to be able to figure that out by using the regular expression. Now, you don't even need to do this history append right here. The reason I'm adding it is because as you go and extend the application, you're going to want to make sure that you have that in your code, because your history is what's going to give you the context over time. And so it's just good coding hygiene, you could say, to include the history and append it as you go. Now, of course, it will get wiped out every time this function is called, but you can totally just move the history into your agent initialization class instead and use it from there. So with that, the last piece of our agent is going to be what happens if we do get a match. This is the cool part. So we're going to use, again, regular expressions here to pull out what our match is. So it's going to be name, comma, args equals match.groups. Now, I won't go too far into what groups are, but essentially it's a functionality of the regular expression model, and groups are the parentheses. So you can have the entire group would be the whole shebang if it's encapsulated by parentheses, and then specific groups within that you can identify using indexing in the group function when you call it. That's a rabbit hole, so I'll let you guys explore that on your own if you're interested, but this is what's going to get us the name and the args when we call match.group. After that, we can say tool is equal to self.tools.get name. So again, we just scroll back up quickly. We set our tools here for the agent as a dictionary. So it has all the tool names, and then inside the key, if you call the correct tool name as the key, you'll get the value which has all the information about the tool. So down here, we're grabbing the tool that has the name that we get out of the matching function. There's one more check to do here, which is going to be if tool pass, and it's going to be where you're going to do something if you get the tool. And I'm not even going to do an else statement here. You could presumably do something like else, return error or what have you right here. But again, for the sake of this video, we'll assume we're only asking it to generate tools that it knows it has access to. And if it doesn't, if something happened, then it's just not going to return anything if it thought it should have been a tool. So if tool, we need to go and importantly check for arguments. So in our time tool, we don't have any arguments, but let's say we do have a function that has an argument in it. We might want to go and check for the argument and pass it in. And that's what we did. If I go back to the tool run function up here, we're looking for an argument if the argument is not an empty string, else we just call the function as is. And that can totally be extended if you're using functions with multiple arguments. It's just going to get a lot more complex with the regular expression as you're matching in the agent. So check for arguments. Results is equal to tool.run arg if arg else tool.run, and we're going to do an empty string here. So that's where that empty string gets handled. And I'm going to change this args up here to just a single arg because we're only handling one. And then again, just like we did below, I'll go and grab this little block that we filled in. We want to append the history just because it's helpful. And we're actually going to do that twice. So let me actually just grab the whole thing. So the first one is going to be the history.append for the assistant response. So if it returns something, this is just to keep track of what it originally responds. The second one is going to be the actual tool call, because those are two separate things that are happening. The agent is first generating a response up here with the model call, which will get saved in this first history.append call right here. And then the second history.append call is actually going to be tool instead of assistant. So I'm going to go in and modify this to say tool right here, and then content should be result, which is just above. Just like that. And then the last step, just as we did below, is we actually need to return the response to the agent. And you'll remember that earlier when we were building our tool, I said I built this agent so that when you make a tool call, the tool call itself returns a string. So you don't have to worry about reformatting or anything like that. You can just go ahead and return the result right back to your agent. So result.strip, just like that. And with that, you should have everything in your agent code. So I'll go back and just do a quick overview. We have our initial setup here, which sets up the three main components of an agent. You have the model, the tools, and then the instructions. And then the second function under that is going to be our run function. So you start by defining our initial history, which you can extend or even move into the model if you prefer. In this case, it's going to be wiped out and replaced every time. After that, you have to define a method for the agent to understand that a tool call is happening. So you have to give it some check to say true or false, there's a tool call. I'm using regular expressions here. After that, you call the model with your completion. You'll check for a match. And then depending on if you see a match, you'll do one of two things, which is either, in the case there's no match, you go and return the response directly in the else case. Or if you do find a tool match, you attempt the tool call, and then you return the response of the tool call to the user. Great. So now we finished the tools, we finished the models, and we finished our agent class, which are the three main components in the source code. So just to show that we've visually completed it, I'll close those in the sidebar here. We might reopen it later, but that's our boundary line as we move into the main function of this code. First thing we need to do is do the configuration file. So I'm going to go ahead and paste directly, and I'll show you what I pasted and talk you through it. There's three keys that we're using. First one is the model key. So we discussed this all the way at the beginning in LM Studio. You have different models you can download, and this model key is going to correspond to the specific model you've selected. If you followed along the video and chose Llama 3.23b instruct, you can use exactly this model key with Hugging Quant / Llama 3.23b instruct, and it will reference the correct model. Now, as I mentioned earlier, LM Studio also allows just-in-time model loading. So if you were to choose a different model here, you don't have to go and replace the model. You can just let it go. And if you have that option enabled in LM Studio, when you actually run the code, it's going to say, hey, that's not the model that I have loaded, and it's going to load an additional model on top. Now, you want to be careful with your resources there, but I just want you to be aware that you can do that. The other two are pretty straightforward as well because they're the fallbacks that we defined earlier in our model interface class. So the LM Studio URL is just this base localhost 1234/v1 that matches the ChatGPT endpoint, and it's what allows us to use the OpenAI client function. And then the second one is the LM Studio API key. Again, this is more of a requirement for the OpenAI client that requires an API key, so you can just put LM Studio here or what have you, and it will work just fine. That's all you need. Feel free to extend this more if you want to have more configuration files or even replace this with JSON, whatever you need to do. I chose YAML because as a developer, it's a lot more readable, and I can go in and do more interesting things. You know, let's say I want to have a temp key like this. Oh, hey, I can make a sub dictionary that has additional keys in there that are only with that class. So YAML is really powerful. And if you don't use it, then here's a good introduction to it. Great. So now that we have the configuration ready, the last piece we need to build is the main file. This is what's going to put all the pieces that we've previously built together and actually call your agent. So as usual, we'll start with a couple imports. First one is going to be import async IO. This is a Python standard library to handle asynchronous functions so that you can call multiple things at once and it will handle the memory for you. We're also going to need from source.agent, we'll need the agent class, just like that. And then from our tools class, from tools, we'll import both of those things that we created at the end. So we'll have tools, the list, and we'll have tool descriptions, the list of strings that we're passing into the instructions. Then we'll have here our main function, so def main, which is going to take no inputs. And I do this a little bit like C style, so you can kind of see how it's broken apart. And at the bottom, we'll just add if name equals main. This is where we'll call our main function, just like that. So now we can go and start filling in our main function. I'm going to fill in a couple things and then go back and fill them in. So we have instructions. That's going to equal, and I'm going to do a tuple. Under that, we'll have agent equals, and I'll just put an empty agent class here, which again, I'll go back and fill. And then below that, we'll have the run loop, which is going to be very similar to a chatbot if you've either watched the video before or you've built a chatbot on your own. Now, I'm going to fill in the agent really quickly, and then we'll go back on the instructions because I want to spend a little bit of time there to just explain what's going on. So the agent is very simple. It's going to be tools equals tools that you pass into it. And then instructions equals instructions. And this should be pretty familiar because we just built the agent class, and those are the two things you have to pass into it. The model interface is instantiated within the agent class already, so you don't have to worry about that. Now, we know what the tools are because we built those, but the instructions is what I've continued to allude to, but we haven't put that together. The reason I haven't said much about the instructions is because they can be very subjective. So what I have come up with in this video is one thing that works for me, but if you change your use case, it might be helpful for you to explore how changing your instructions can actually help you to get more complex, different, better behavior out of your model, you name it. That is a very fluid scale of things. What's better for one person might be worse for another. So it's really important that you spend time on the instructions because this is where you're setting your behavior, your model context, your model alignment. These are very important things, especially when you're looking at going into production where there's a higher level of trust required because the instructions are the pillar and foundation for all of that. So I have 4 lines in my instructions, so I'm just going to set those up here so that they're a little bit easier. No commas, excuse me. set them up so they're a little easier to understand. So the first one is going to be, you are a tool calling agent, and I'll add a dash there. You're a tool calling agent that may use the following tools by responding according to their instructions. New line. So that's it. And just so we can see the whole thing, I'll close this side tab for a second. So you're a tool calling agent that may use the following tools by responding according to their instructions. After that, we're going to give it a little identifier and say available tools. Available tools, and again, new line. What's really cool about this is you're formatting it like a human would want to read this, and that's really the power of agents, is that they allow you to really engage from a human perspective by using language, and then they can take the formatting that you give it that you're required to have as a human, turn it into computer language, and go do it all on the computer and then deliver the result back as language for humans. Computer language is also the technical term for how computers talk to each other. After that, we have an F string. This is going to be where we drop in our tool descriptions. So that is from the previous slide, that little piece that we built, that's the bulleted list. So just for clarity, I'll go back right down here. So it describes the tools for the system prompt, and you'll see it's a nice little separation of new lines with all your tools. In our case, just the time tool, and then it says prints the current date and time, usage is return time. The last line under here is, if no tool is needed, respond with the final answer, period. And that's it. So for our agent, these are the instructions that it's going to get today. Now, I talked a lot about the nuance, I talked a lot about how they respond differently, and I just want to talk a bit about why that happens here. Your agent is only going to have the context that you give it. So for the same reason that you need to give it a function to tell the time, you need to give it a little bit of context to know where within its weights it essentially needs to land to get you the right answer. And it doesn't have any understanding of the tools that you give it without you specifically describing the tools. So the first failure point is when you're in your tools file over here. If you do a poor job of defining what the tool is able to do in the description, your agent might not understand how it works. So you could, for example, and I'll just delete this for now and then I'll undo it and add it back. You could, for example, have this as the description. Time prints current date and time. But then when the agent gets back to the main file right here and you're designing the instructions, oh no, how do I use the tool? You've told it that it's an agent that can call tools, but there's no more usage function. So it's really important that you think about, how do I break apart these two different pieces so that the agent has all the context that it needs? So if you were to remove it from that tools file, you could add it back here and say, under available tools, something like, to use the tools, give the function name and then parentheses, or something similar. But in this case, with my experimentation, I found that just providing the usage directly to the agent with the tool itself gave much more reliable output, so that's why I'm going to leave it like that. Now again, you can go do a lot of stuff with this, so you can potentially add here, I only want you to respond in rhymes, things like that. There's a lot of flexibility with agents, and that's why it's really cool to even do them at the edge, because you can combine that inherent flexibility with the flexibility of using unique data sets that you wouldn't want to load up to the cloud. So with that, we have our instructions set. We have our agent that is consuming the tools and consuming the instructions. The last piece we need to do is put together the run loop. It's going to be fairly simple. So the first thing we'll have is just a print statement for the user, and this is going to be to tell them what's going on. So I'll say something first, actually, that's like, hello, you are now chatting with your agent. Under that, we'll say type, and we'll give them a couple exit parameters in case they're done talking to the agent. Type exit or quit or bye to end the chat. So again, these are going to be printed out at the top. the very first thing the user sees when they run the program. After that, we have our while true loop. And we're going to fill this in with the agent behavior. Very simple. All you're doing here is the conversational piece of the agent and the user. So you just first need to take in the user input. Then you need to figure out if that's one of these statements that will break you out of the chat. And then if it's not, you're just going to go call the agent with whatever the user passed in. So we'll do user input is equal to input. And then we have a prompt for the user. So I'll just, again, stick with prompts that I've used in the past, which is going to be u with a space, dot strip. So we strip off any hidden characters if they happen. So we'll see u. And then second thing is, like I mentioned, we need to check and make sure the user is not putting in one of these keywords that ends the chat. And by the way, you can also add additional keywords if you'd like and do several layers of checks. But for simplicity's sake, I'm only going to be checking for exiting out of the chat. So if user input dot lower is in either exit or quit. What's the other? Oops. Exit or quit or buy. And I don't need the or there because I'm not talking out loud. You'll just print goodbye and then you can exit out. So goodbye. And I'll put a break right here. Again, more complicated behavior is, often appreciated by users, but for simplicity, we're just going to leave it like that. Then right under that, because we've now checked to see if the user wants to quit out, we can actually just handle the response. So result is going to be async io.run. So we're invoking the asynchronous nature. And it's going to be agent.run user underscore input. And right under that, in case we get a response, we'll do print and we'll do an F string here and we'll say agent with a space. And then we'll add in the result that we got back. And we should probably add a strip there as well in case we get any characters. I know that was handled in the agent, but it's just good to check your bases here. So that's it. The main function is very simple. It's just this little loop that's a chatbot loop. You set up your agent and your instructions as we called them. And now we're ready to run. I'm going to set up the virtual environment here that we need to run our agent. So first things first is I'm going to print out all the Python versions I have. So I make sure I'm making a virtual environment the right version. I want the Python 3.12 version that I have there. So I'm going to do Python -m venv, and I'm going to do agent venv. That's going to create my virtual environment. So we'll give it a second. And because my default was already set to 3.12, I didn't have to specify the version. So I'll activate my environment really quickly. So we'll do agent venv, and then it's scripts with a capital S activate. You'll have to modify that for your platform if you're not running on Windows. And then I'll verify my Python version. Python --version. There we go. I'm running Python 3.12.6. Next step is to install the two requirements. So in this case, there weren't too many, so I didn't do a requirements.txt. It's going to be pip install OpenAI for the OpenAI client, and then YAML for the YAML library. Those will go ahead and install. And we see we have an update of pip here, but I don't really need that, so I'm going to clear this out. And now we should be ready to go. The last thing I'm going to do is I'm just going to do Python to make sure my installation works, and I'll try to import. So I'll do from OpenAI import OpenAI, just like last time. And if that returns, your virtual environment is set up. And now let's get to the code. Before we run the code, I just want to take you guys back through a couple errors that I found that I want to fix in case you're following along at home with the code. First one is going to be in the main file. At the top in my imports, I have from tools, import tools, and tool descriptions. That should actually be source.tools. So I'm going to go ahead and modify that so it's source.tools. And that will correctly reference the items and objects from the other file. The second two are going to be an agent.py. So the first one is going to be the run function as a whole. That actually needs to be an asynchronous function because it's working with async IO, and I forgot to add that there. So if you just add async as a keyword in front of def, you'll be good to go with that one. And then the last error is down here under the match. So once you've done the match call and you check if there's a match, right underneath that, you actually pull out the name and the argument from match.group, but that should instead be match.groups with an S. And that's because we don't have a single group in our regular expression. We actually have two. So the first group is going to be this first set of parentheses, which is the function name. And then the second group is going to be this set of parentheses right here, which is the arguments within the function. And with those two changes in place, we're ready to run the code. So I'll pull up my terminal again. Our virtual environment is activated here. So all we need to do now is call python main.py. And that's going to load our agent. So hello, you're now chatting with your agent. Type exit or quit or bye to end the chat. So I want to demonstrate two things. First thing we're going to do is I'm just going to ask it a generic question. So I'll say, what is the capital of France? And this is just so you see that it's a regular chatbot. So you can talk to this just as you would any other chatbot that doesn't have agentic capabilities. And as you can see, it returns the capital of France as Paris, which is correct. Might be wrong because it's probabilistic, but usually that's a pretty safe question to ask. Now, the interesting piece is when we go and try to call the function. You remember from the beginning, LLMs do not have time as a construct that they can access. So if you ask it what time it is and it's not an agent, it's going to tell you something, but it's not going to be correct. So I'm going to say, what time is it? And it'll sit and process for a second. And then it returns. So the current time is 11:15 a.m. on the 10th of June, 2025, which is just about right by my estimation. The clock down on the bottom is saying 11:16, but close enough. And with that, we've now verified that we have a working agent, because if we didn't have that tool, it would not have given us the correct time. And that's about it that you need to know for the agents. So I hope you got a lot out of this video. It was really great to make. One more time, if you want to see the code, that's going to be at github.com/thatrandomfrenchdude/local-agent. And all the original code is there, as well as any of the updates that I make to it over time. Feel free to reach out to me if you have any questions or input. And I hope to hear from you guys soon on the Qualcomm Developer Discord. So with that, thanks for watching and see you next time.